Testing. Hi there, guys. My name is Rohan Bivit, and today we are going to be talking about freezing, melting, and boiling points. Today we're going to be talking about freezing points, melting points, and the boiling points. Okay, we're going to be talking about what they are and what specifically they are and how and why it happens. Okay, so as we know, okay. Uh, so have you ever noticed, like, let's say you go to the fridge, you open the fridge door, you take maybe some ice packets, right? You take some, you put it in a drink, maybe, and let's say you decide to take it and you pour some hot water in it and it starts melting, right? Or maybe put something hot on the ice cube and it starts melting, right? Then you also noticed you saw some water boiling, right? And then all this vapor is coming out. But like we're specifically talking about what specific temperature is this happening at, you might wonder. Well, the thing is, okay, one thing we have to get straight is that temperature isn't just about feeling hot or cold, okay? It's also about change. It's also about change in temperature, okay? Which basically equals to how does matter transform, okay? How does it transform? So let's say we take a ice cube, okay? We slice it in half, and or not slice it in half, but we take a microscope and look at it microscopically. We find a bunch of particles, atoms, and molecules tightly packed together, okay? And all these molecules are fully packed, creating a solid, okay? And the thing is, the thing with all those particles and stuff is that always in these particles are always in motion. How fast these particles move depends on how hot the object is. So right now it's an ice cube. It's frozen, right? It's fully packed and it's moving very slowly. It is a solid, okay? Now that's mainly how a solid is. Now let's say we heat it down, okay? We heat it and now the molecules are starting to get a bit more faster and they start to spread a bit, okay? Now we turn the solid into a liquid. Okay, so now it's a liquid. So now you take your ice and you turn it into water. Okay? Now the melt, so that's basically how that works. Okay? And let's say we apply a bit more heat to it. It gets so fast and so far apart that it gets so light, which allows it to start floating into the air. Okay? It becomes a gas, okay, as it floats in the air as vapor, okay. So that's how all these things work. Now, if once we go back to solid, okay, solids. Now we're also gonna have to look at what specific temperature do these objects have, okay. And the thing is, it depends on the material as well. For example, again, an ice cube, what'd you say, melts at around 0 degrees Celsius. So it melts down at 0 degrees Celsius. Now, not only that, wax, for example, heats or melts at, what'd you say, higher temperatures, just a bit. But iron and gold, for example, need a lot of heat to melt it down. Okay? That's just one example. Now it turns into a liquid. Let's say we heat it a bit more. For example, an ice cube, right? It turns into water. It takes around 100 degrees Celsius to turn the liquid into a gas. Okay? Now, what about freezing the object? We cool it down. Okay? So when we're cooling an object down, okay? As we cool it down, again, these are very different from, like, it depends on the material, again, on how cold it has to get to cool down. But for water to turn back into ice, it takes around, again, 0 degrees Celsius. But you might be wondering, how does it turn from how does both 0 degrees Celsius for melting and for freezing? Okay, well, 0 degrees Celsius for water, okay, is a very special type of temperature. It's at an equilibrium and balance. You can think of it as a tipping point. So right now it's at 0 degrees Celsius, and right now it's like this. So any a bit more little heat, or maybe just a little bit cooler, right? It could tip the scale, and it can change the form. Okay, that's basically what freezing, melting, and boiling points are, and that's basically it. Thank you for watching this video, and hope to see you next time. Bye bye.